Hello, Pre Calc. This is a video over some remaining topics in Chapter 12.2, specifically one-sided limits and a specific limit from calculus that leads to a formula called the difference quotient. I have both of my things out here. I got Desmos ready to go. I got my calculator ready to go. And we're going to talk about these. You should have both ready to go also, and we'll talk about one-sided limits. All right, so we've learned that up to this point, we've learned that two things. Well, if we're going to have a limit exist at a point, they have to come together. And when they do this thing right here, they don't actually have a limit. Well, there's another idea here with that is, okay, they don't have a limit at the point, but what's really going on the two branches? So we talk about what's happening in the graph, coming in from one side or coming in from the other. And yes, the idea is the point itself, the spot does not have a limit because we don't get this. But the one-sided limit is, okay, it doesn't have a limit, but what's happening on this side and what's happening on this side. And that's really the overriding concept here. So I'm going to start with this one. I'm going to plug this into my calculator. That one is, actually I'll plug it in on Desmos here. I think Desmos is a good place to plug this one in. So go ahead and take Desmos and plug in the absolute value of 2x over x. The absolute value of 2x divided by x. And what I get when I get that is I get that picture. See if you can see that. It's kind of blurry. Oh. There we go. Oh, I'm going to shut a light off here. Hold on a second. Class. That might help us see this a little bit better. I still can't see it on my calculator. Oh, there it almost was. All right. Well, hopefully you've plugged that in. And I notice on this graph what I get here is I get this. I get part of the graph that comes in like this, and then the other part of the graph that is up here like this. And there's really two chunks of the graph. And the limit at 0, here's 0. At 0, I get this idea where these two lines, like this, they're coming in and they don't have. So the answer here, what is the limit at 0? Well, the limit is the limit does not exist, DNE. Okay? We have a limit there that does not exist because that's what happens. But what this is saying is what happens close to 0 on each side of 0. So here we go. The limit as x approaches 0 negative. What that means right there, that little negative means from the left. So what happens from the left? Approach 0 from the negative side. So get closer and closer and closer to 0 from the left side. So here I am. It's chugging along here. And on the left side, no limit at the point, but on the left side, what's happening? Well, it's approaching this little y value right here. And I think if I check my calculator, that y value, I'm going to zoom in on my point here. Yep, I got a y value on my graph, y value of -2. So the answer as x approaches 0 from the left is -2. This one, the limit as x approaches 0, and that plus sign means from the right. So here I am on the graph, and I'm going to get closer and closer and closer and closer to 0 on the right side. And my value right there is +2. So from the right, I get +2. So underneath these two bubbles, let's see here. From the left, I get -2. From the right, I get +2. And that is correct. Let's go down and let's try another one. Okay? The limit as x approaches 0 from the left of x ln x. I'm going to use my graphing calculator this time. Maybe it'll work a little bit better here. You can see it. So I'm going to type in x ln x, and I'm going to graph that. Okay, and I get that picture right there. It's just blurry right now. All right, there we go. I can't even really see it. You go ahead and plug this in. X ln of x. And what I do is I get this graph that looks something like, I get this graph that starts here and kind of looks like almost like a Nike swoosh, goes out like that. So let's approach x from the left. Well, if I approach 0 from the left, I get nothing. There is no graph. So approach 0 from the left, that answers DNE. Let's approach 0 from the right. Well, it's going to hook down up there, and it's going to get closer and closer and closer to 0. So that one is 0. What would be the limit as x approaches 0 from both sides? Well, you got nothing over here, so you got that, and then you got, well, we don't get this, so the limit would be does not exist. The left side limit also does not exist. The right side limit is 0. And let's do a piecewise one. I'm going to graph it down here. I'm just going to graph this one by hand. Having some issues with my graphing utility today showing up. So let's do this one. Let's go x plus 1. So plus 1 right there, and then it's up 1 over 1, my slope. Goes through 1, up 1 over 1, and that's for all x is greater than 0. So I will put an open circle, and I'll go up 1 over 1, and that chunk right there, and you can plug that into decimals if you want. And negative x squared, which is an upside down parabola like this. And then that's for all x is less than or equal to 0. So I want a solid circle there, and I want that. Okay? All right, so the limit as x approaches 0 from the left. So I'll go from the left. As I approach 0 from the left, I get a value of 0. Let's approach 0 from the right. As I approach 0 from the right, I get a value of 1. What is the limit at 0? What would this answer be? What would be the limit as x approaches 0 from both sides? Well, I have this parabola and I have this line, and they don't come together. This one is D and E. I should mention here also there are a few problems along the way that just say find f of 2, and it doesn't have a limit at all. There's a couple problems on a worksheet or a Canvas quiz or something like that. What they want you to do is they just want you to find the function value at 2 when they give you this. And it's not limit notation. They don't use limit, just f of 2. So what they literally want you to do is they want you to go over to 2. Well, that would be up on this graph. And since it's on that graph, what I can do is I can take the 2 and I can plug it into that graph, which is this right here. Or if you had it on decimals, you could go over to 2 up to the graph and you could trace that value. You could find out what that y value is. I'm going to go ahead and take the 2 and plug it in there. 2 plus 1 is 3. So over 2, I'm at 3. See if you can determine what f of negative 2 is right now. Hit pause and see if you can do that. All right, negative 2. I go left 2. I go down to the graph. It's on this chunk of the graph, so I'll plug negative 2 in there. So it's negative 2 squared. That's positive 4 with a negative sign out in front, so I got negative 4 for my answer. If you go over the graph down here, you should be at negative 4 on the y-axis. And that's one-sided limits. The second thing today is called the difference quotient. It is a specific limit. It has 3 parts. It is a formula. It is like the quadratic formula. It does not change, and you will see where it comes from soon. But we're gonna find the specific limit of the difference quotient, and it says the limit as h approaches 0 of f of x plus h minus f of x all over h. And there's really what there are is there's 3 chunks. There's that chunk. There's that chunk. And then there's the h on the bottom. Okay? And let's try to find this limit just with direct substitution. I'm going to take the 0 and I'm going to plug it in for the h's. Find the limit as h approaches 0 of this formula. So I plug the h's in. I plug the 0 in, and I get what I get is I get f of x plus 0 minus f of x all over 0. Well, the top is really f of x plus 0 is f of x minus f of x all over 0. F of x minus f of x is 0 over 0. And it says, through direct substitution, we get an answer of 0 over 0, which we know we can't do. This actually has a name. The name of this is called the indeterminate form. What it basically means is that when we do this problem like this, and we get 0 over 0, we have to do some algebra with it. We have to do some of those weird techniques that we learned earlier to try to find the limit. So for this function, find this limit for this function. And we'll use this thing called the dividing out technique to do it. And then we'll get our answer. All right, so for the function, use this formula, apply this formula on this guy. So I'm gonna use some colors here, okay? So first of all, I'm just gonna chunk it up. I'm gonna find that. Okay? So I got the limit. This part here I'll leave in black. I got the limit as h approaches 0 of f of x plus h. And what this is telling me to do is this is telling me to take x plus h and plug it in for that x. F of x plus h says take whatever's inside the parentheses, plug it in for your x's. So in red, I'm going to take 5 minus 6 times x plus h. That went in for that, and I rewrote it. 5 minus 6, 5 minus 6, x plus h went in for that x. Minus f of x. Minus, well, f of x is the function. So I'll rewrite the function. 5 minus 6x all over my h value. And those are the three chunks. This value plugged in and rewritten. This value rewritten all over the h. And what we're going to be able to do with these is we're going to be able to do some fancy algebra to come up with the limit. The limit as h goes to 0. So here we go. We're going to go 5 minus 6x minus 6h. And then we have minus 5 plus 6x. All over h. All I did on that problem right there, was I distributed the 6 through and I distributed the negative through. Okay? At this point, you're going to have some nice things happen. And I still have the limit as h goes to 0. And by nice things happen, you're going to get some things to whap out. The 6x's are gone. 5's are gone. And I'm left with the limit as h goes to 0 of negative 6h all over h. And at this point, a lot of times what's going to happen is you're going to have this happen. And I'm left with the limit as h goes to 0 of negative 6. And you can, after you've whacked out those h's, after they go away, what you can do is you can take that 0 value right there and you can shove it into the equation. In this case, it's kind of weird, but there is no place to shove it in. I try to shove it in for the h, but it's the limit of a constant, and we learned the limit of the constant is the value of the constant. So the limit as h goes to 0 of negative 6 is negative 6, and that is the answer. We're going to try another one of these. In fact, we're going to end up doing this formula quite a number of times in quite a number of situations. It is a formula that is the basis of calculus, the first semester of calculus. We want to make sure that we can do this. All right, same type of deal. We have a function, we have a formula, we have pieces of the formula. So I'm going to find the limit as h goes to 0 of f of x plus h. I'll do that in red. So I'm going to take x plus h, I'm going to plug it in for the x. X plus h quantity squared minus 1. All I did was I took that part of the formula, the x plus h value, I plugged it in for that x. I got that. minus f of x. I'm going to use blue. Minus my f of x is the function. So minus the function x squared minus 1. Common mistake is to not use the parentheses there. Make sure you use the parentheses. All over h. That's the setup. That's the setup using the formula. The red part, plug it in, minus the function, all over h. Now it's algebra. So we're going to find the limit as h goes to 0 of, well, x plus h squared is really x plus h times x plus h. I'm going to have to FOIL. Here I have a minus 1, and then I have minus x squared plus 1, all over my h value. So all I did was I wrote the binomial squared as 2 binomials. I brought down the 1. I distributed the minus sign through. Let's find the limit as h goes to 0 of, let's FOIL, x squared, xh and xh. There's an xh there and another xh there. I'm going to write that as 2xh. I've already done x times x for x squared. There's 2xh, and then those two make plus h squared. Minus 1, that minus 1 comes down. So this is FOILed, minus 1, minus x squared plus 1, all over h. And at this point, again, you're going to get some things that are going to cancel out. So I notice the x squareds go away. I notice the 1s go away. And I can come up here. I can find the limit as h goes to 0. What's left over, which is 2xh plus h squared all over h. And if I plug a 0 in, I get 0 plus 0 over 0. I still get 0 over 0. I still get that indeterminate form. So I'm still not done simplifying. I'm going to go with the limit as h goes to 0. And I notice there's an h in both, so I'm going to factor an h out. And I'm left with 2x. If I pull an h out of there, I'm left with 2x. If I pull an h out of there, I'm left with plus h all over h. And at that step, your h's can actually wipe each other out right there. And I can find the limit as h goes to 0 of 2x plus h. Which means what I can do is I can take that 0 value and I can use direct substitution. I can plug it in right there, direct substitution. I can plug it in, and I get 2x plus 0, which is just simply 2x. This formula on this function yields an answer of 2x. And that is really very powerful. We will do a lot with that. That it even has a special name as we go through it. Okay. What you can do with the answers that you got from this is find specific limits at specific spots. Okay. So if you had that 2x answer, and they wanted you to find the limit as x goes to -3, is you can actually take the -3 and then plug it in and get -6. I think this is for that problem. Yes, so the 2x value, you take that, you plug it in, you get -6. If I plug 0 into the 2x value, what you're going to get is you're going to get 0. And if I plug 50 in, well, 2 times 50 is 100, so you could find actually specific limits at specific spots. All right, the last piece of this. Let's do one piecewise one, and I like this one down here. Let's do this guy right here. Let's zoom out a little bit, and that'll be it. We're gonna end with a piecewise limit. We've done a couple of these, but I do want to do these on my also on here, and we'll be done. So 4 minus x squared. You guys are used to writing this as -x squared plus 4. So I'll go up 1, 2, 3, 4, and -x squared means it's upside down. If you wanted to graph that, you could. Looks like that. And for this chunk, we want all x's less than 1. So at 1, if I plug a 1 in, I would be at 3. So if I go over 1 and up 3, and it's or equal to, so it's that value right there. And I don't actually want any of that. The next one, I'm going to plug in negative x plus 3. I don't like how that's written, so I turned it around. So I go up 3, and then that's down 1 over 1. Negative 1 over 1. So it's down 1 over 1, down 1 over 1. And that graph looks like that. That also up there. But I want all x's greater than 1, so I'll put an open circle there. And I will make it solid. Okay? So what I would like you to do is I would like you to pause the video. I don't want you to think about this. There's a spot on this graph that if you go to that spot and I ask you for the limit as x approaches something, you would get the limit does not exist. But if you go to that spot, it does have one-sided limits. Can you pick that spot out? Press pause and see if you can figure it out. The spot would be right here. You find the limit as x goes to 1. Right here, the limit of f of x as x goes to 1. If I approach 1 from both sides, the limit does not exist. But if I found the limit as x approaches, let's approach 1, negative, which means 1 from the left. I should probably have this in blue. Find the limit as I approach 1 from the left. The limit as x approaches 1 from the left, well, that value is 3. I'm up here at 3. And over here, the limit as x approaches 1 from the right is a value of 2. And there's actually a theorem in calculus that says if the one-sided limits are different, then the limit, the point won't actually have a value for the limit. It's a down the road thing for you, but right now, that's what we got. So now, the limit as x approaches negative 10. So here at negative 10, I'm way down here. I'm way off the graph. Well, if you ever don't know a limit or don't have decimals out, you can just take that value and you can plug it in the right equation. It's the blue half. It's that half. So I plug negative 10 in there. I get 4 minus negative 10 squared is 100. So 4 minus 100 is negative 96. And that's a polynomial, and it's continuous down there, so we're good. And then as I approach 2, I can just use my graph as I go to 2. So over to 2, up to the graph, over to 1. This one is 1. That's the end of the video.